All right, everybody. So what I want to do is walk through a full example here where we are running a regression as a hypothesis test. So one of the first things that we need to figure out is what variable is independent and what variable is dependent. And one of the things that I realized later that I forgot to mention some alternate names for those. So your independent variable is your x variable, your dependent is your y. Some textbooks may also call them the explanatory and the response variables, because that is the independent one can be anything. It explains the response that we see, kind of like the dependent one depends upon this one. This one explains the response that we see. So what we're looking at here is test data from 11 stat students, and it gives the score that they got on their third exam, which was out of 80 points, and then the score they got on a final exam out of 200 points. So it wants to know, can we accurately predict a final exam score of a student if we know their third exam score? So because we are trying to predict the final exam score, that means it is the dependent or the response variable. So the third exam, that's going to be our independent. So what I did, I went ahead and put those in my graphing calculator. So at this time, make sure you have those in there, or you can pause the video and do that. So independent is third exam, dependent is final exam. Okay, so now running the test. So we have our null and alternative and our alpha value that we're looking for here. So as we mentioned in the last video, our null hypothesis is always that rho equals 0. And then the alternative is going to be that rho is not equal to 0. And unless we have reason to believe otherwise, we are going to continue to use 0.05 for alpha. So what we're going to do is we're going to run the linear regression t-test. We're going to get these different values, and we're going to find and interpret those. So I'm going to go to stat, tests, linear regression t-test. So x is in L1, y is in L2. I'm making it not equal. I'm storing my regression equation in y1. And again, just to show you that, it's vars over to y vars, enter for function, and enter for y1. Hang on just a second. Sorry about that, guys. Okay, so now down to calculate. And here's my values that I'm looking at. Okay, so we've got T, which is a typical test statistic, not what we're using as a test statistic here. We've got our p-value. Here's what we're looking at. We've got our alpha. I'm sorry, not our alpha. A, B, R squared, and R. Okay, so A is negative 76.52. B is 3.49. R is 0.51. R squared 0.26. Okay, so the interpretations for these, remember, A is your y-intercept. So when a student scores 0 on the third exam, they will score negative 76.52 on the final. So this is one of those ones where the interpretation, this is nonsense. Okay, we can't accurately use that y-intercept for anything. So no big deal. B is our slope. So as the third exam score increases by 1 point, the final exam score will increase by 3.49 points. Okay, our R value is 0.51. So this is the value that we're looking at the scale from -1 to +1. So it is obviously positive, and 0.5 falls in that middle moderate category between 0.2 and 0.8. So I'm going to say that this is a moderate positive correlation. Okay. R squared is 0.26. So that means 26% of the variation in final exam score can be explained by the relationship between, and I'm going to stop writing, but between the third exam and the final exam. So make a conclusion. And we're going to do this two ways. We're going to do basically what was step 3 and step 4, the critical value and R value, and then the P value. So the first way is with a critical value. So I had posted on